Okay, good morning to everyone. Hello, Dichika. Hello.
हेलो
हाँ, बोलिए सिग्नल जनरेटर तो नहीं हुआ था।
यस सर
सिग्नल जनरेटर हुआ था कि नहीं हुआ था क्लास में?
नो सर
Okay. So today I discuss about the signal generator. So actually, what is signal generator? Signal generator actually it generates a different type of signal, just like an sine wave, triangle, square wave. This type of signal. And mainly the function of signal generator is that it is a produce a known and controllable voltages, and it is used as a power source for the measurement of gain, signal to noise ratio, bandwidth withstanding wave ratio, and others properties. And it is extensively used in measuring the of receiver, radio receiver, and transmitter instrument in provided with the means of modulating the carrier frequency, which is indicated by the dial setting on the front panel of the signal generator. And the modulation is indicated by a meter, and the output signal can be amplitude modulated or the frequency modulated, and modulation may be done by sine wave, square wave, rectangular, or the pulse wave. And these are the conventional element of the signal generator, which are the number one is the RF oscillator, number two is the wide band amplifier, external oscillator, and modulation oscillator, and the last one is the output attenuator. And the carrier frequency, which is generated by a very stable RF oscillator circuit having the constant output over any frequency range, means the carrier frequency which is generated by the stable RF which is used or by L and output voltage or output of frequency of range. And the frequency of oscillation is indicated by the frequency range control and the Ventire dial setting, and the AM or amplitude modulation is provided by an internal sine wave generator or from an external sources, either external sources, and which is produced by the external oscillator. And signal generator is also called an oscillator, and just a Owen bridge oscillator is used in this generator. The signal generator is called oscillator. The oscillator is used as an oscillator when it is used as a Owen bridge oscillator circuit or Owen bridge oscillator. The Owen bridge oscillator is used to in this generator, and the Owen bridge oscillator is the best of audio frequency. Frequency of oscillation can be oscillator, and the frequency can be changed in step by switching the register or different value. And the output of the Owen bridge oscillator goes to the function of the switch, and the function of the switch direct the oscillator output either sine wave amplifier or the square wave shaper. At the output get either square or sine wave, and this output is varied by means of an attenuator. So external oscillator is produced the firstly what happened in Owen bridge oscillator or the generalized signal generator, that firstly the RF oscillator, it's using the LC tank circuit having a constant output voltage, output over any frequency range. Then the frequency oscillation is indicated by the frequency range control, but Ventre dial or from the external source, means here the external source is the external oscillator. The signal generator is called is an oscillator, and when the is used in this generator, the Owen bridge generator, and the frequency of oscillation can be changed by the varying the capacitance of the oscillator. Okay, and the frequency can be changed in step by switching the register in different values, and the output of the Owen bridge oscillator goes to as a function of switch, and the function switch directly output which are and the output we get either square or sine wave, and this output is varied by means of attenuator. Now this is the RF oscillator, this is our wideband amplifier, this is the output attenuator which is externally connected to the external oscillator, and this is our main modulation oscillator. So range and frequency provided by the RF oscillator, and after the wideband it go to the this, and the output can be get according to our requirement, which is sine wave. This instrument generates a frequency range of 1 megahertz. Okay, output is the push-pull amplifier, and for the low output, the impedance is 6000, and the square wave amplitude can be varied from 0 to 20 peak, and it is possible to adjust the symmetry of the square wave from 3 to 70%, and the 3.7 of the power at 220 volt, as the supply frequency is 50 hertz. Okay, and the frequency selector and the front panel of the signal generator consists of the following, means अगर signal generator क्या क्या रहता है, the number is the frequency selector, means which frequency we can select the frequency of in different ranges, and it is also varies continuously with the ratio of 1 is to 11, and the scale is a non-linear scale. And another is the frequency multiplier. So what is the frequency multiplier and what is the function is that it selects the frequency range over 5 decade from 7 megahertz, and attributes the sine waves in 3 decades of multiplying of 1, 0.1 and 0.0.01, and the variable amplitude it attenuates the continuous of the square wave from 32% to 70 30% to 70%. Just 1 minute. And the amplitude it attenuates the square wave output continuously. And function switch, it select either sine wave or square wave, and the output variable, this provide the sine wave or square wave at the output end. So function switch is select either with either sine wave or square wave, and avoid the sine wave or square wave at the output. And last one is the sync. This is the terminal. This terminal is used to provide of internal signal with an external जा रहा है और एक्सटर्नल ऑसिलेटर से मेरे को से सॉरी एक्सटर्नल ऑसिलेटर से एक एक्सटर्नल सिग्नल जा रहा है. तो ये सिंक्रोनस बटन और सिंक्रोनस स्विच विच synchronize the two signal, which is the internal signal and another is the external signal. Number 10 is the on off switch. On off switch. Now what is now pulse generated? How to generate the pulse or square by using signal generator. So this generator, just 1 minute. Okay. So these generator are combination with the CRO. They provide the both quantitative and qualitative information. They are made use of transient response of testing of the amplifier, and the fundamental difference between pulse generator and square wave generator is the due to cycle. The fundamental difference between pulse generator and the square wave generator is that it's the due to cycle. The due to cycle A is the square wave to cycle, and required pulse of the requirement of a pulse. The pulse should have minimum distortion and show that any distortion in this display is slowly due to the circuit under test. And the basic characteristic of the pulses are rise time, overshoot, or ringing, sag, or undershoot, and the pulse should have the sufficient maximum amplitude if the appropriate output power is required by the test circuit. And for magnetic core memory, the attenuation range should be adequate to produce a small amplitude pulse to prevent over a driving some. Number 4 is the range of frequency control of the pulse generation. Range of frequency is the pulse generation, which is PRR, pulse repetition. The needs of the experiment. For example, the repetition frequency is 100 megahertz is required for testing fast circuit, and other generator have the pulse of burst features which allow than the continuous output. So number 4, I again repeat this, the range of the frequency control needs of our experiment. For example, the repetition of the 100 megahertz is required for testing fast circuit which allow a train of pulses rather than a continuous output. And some pulse generator can be triggered by an external. Number 5 is the pulse generator can be triggered by an externally applied trigger signal, and conversely pulse generator can be used to trigger signal, and which differentiator circuit, the output of impedance of the pulse generator is another important consideration. In the first, pulse system of generator should be matched to the cable, and the cable to the test, and mismatch would cause the energy to be reflected back to the generator by test circuit, and this may be reflected by generator of the pulses, and DC coupling of the output circuit is needed, and DC bias level is maintained. The circuit for the pulse generator is multi-vibrator. So this is the laboratory type of square wave or pulse wave generator. Here is the symmetrically current source, and this is the lower current source. This is the our switching circuit, and here is the multiplier, the ramp capacitor, and is the symmetrical and synchronous circuit. And 600 ohm output is the 1500 ohm, and this is the Tiger output circuit. This is the Tiger output circuit. So this is step attenuated at the amplitude. The frequency range of this instrument is called step with 7 decay, and with a linearly calibrated dial for continuous adjustment. And the duty cycle, two independent outputs are available, and the 50 ohm source that supply the pulse rise and fall time is a 5-volt peak of amplitude, and the 600 ohm source which supplies the pulse falls of time of 700 nanosecond amplitude. So here two output, one is 600 output and the 550. The duty cycle can be varied from 25 to, and the for two output dependent output are available. Number one is the 50 ohms output, and the source for 50 ohms output that supplies the pulse and the rise time and fall time of the 5 nanosecond at, and for the 6 and the 600 ohms, the source which supplies the pulses a rise and fall time with a rise and fall time of 70 nanosecond or at the 30-volt peak amplitude. And the instrument can be operate as a pre-running instrument, operate as a pre-running operate as a pre-running generator, or it can be synchronized with a external signal circuit. And the basic generating loop consists of a current capacitor and figure. So it is symmetric figure. The upper current source supply a constant current to the capacitor, increase linear of the ramp voltage is reached at the upper figure changes the state. So here the upper voltage source or upper capacitor, and the capacitor voltage increases linearly, and when the positive slope of the ramp voltage reaches the upper limit set by the internal circuit component, and then in the symmetrical change his state changes the state, and the trigger circuit output becomes negative, and reverse condition of the current switch means this switch will be reverse direction. Switch is the reverse, and the and of the current switch, and the capacitor is discharges. Previously it is be charges up, and now the capacitor is discharges linearly, controlled by the lower current source. Previously the upper current source, now is the job negative, then the it is used as by lower current source. So the capacitor discharges linearly, controlled lower current source, and when it then the predefined lower level, just आगे क्या लिमिट था, जब अपर लिमिट ए हो जाता है, लिमिट में रीच कर जाता है, तब हम लोग क्या तब क्या होता है, सिमेट्रिकल उसका स्टेट है। ओके, सो ग्रेविटी कंडीशन में आ जाता है। उसके बाद क्या होता है, मेरा कैपेसिटर linearly and it is controlled by the our lower current source. This current source, there will be two current source, one is the upper current source and another is the lower current source. And again, when the negative it reaches as a predetermined lower level, then it trigger switches back its original state and the entire process is repeated. Means एक बार हाई होगा, मीन्स अपर करंट सोर्स के कारण मेरा जो कैपेसिटर है वो चार्जेस होगा और इंक्रीज करेगा, और वो भी लिनियरली होगा ड्यू टू द लोअर करंट सोर्सेज के। जब वो जो प्री डिफाइंड मेरा उसका स्टेट को चेंज कर देगा एंड बैक इट्स द नॉर्मल और ओरिजिनल स्टेट, then the entire process is repeatedly, the ratio of I1 slash I1 by I2 determines the two cycle, and the control by symmetry control by this is control control, and the sum of I1 plus I2 determine the frequency, and the size of the capacitor is selected multiplier switch, and the unit is powered by the internal supply voltage, regulated voltage for all stage of instrument. So how we can is the ratio of upper current source, means I1 by the frequency sum of these two, means I1 plus I2 determines the frequency. Signal generator application, the some frequency measured signal generator. The signal generator such as sine wave, I already tell this, such as sine wave, square wave, triangle wave, sawtooth wave, pulse train, etc. And it can generate varieties of waveform. It is widely used in application like an electronics troubleshooting and development or testing on an instrument for the performance of the electronic instrument, such as application as a signal generator, a known and frequency. So signal generator is an instrument and which can produce different type of waveform such as sine wave, square wave, triangle, pulse trains, and it's generate a variety of waveform, and it is widely used in a electronic troubleshooting, anti-development, or testing the performance of the electronic equipment. Okay, so in such application, the signal generator used to provide the known test condition, means that desired signal of known amplitude and frequency. Hence, the following precaution measures should be taken while using the signal generator for an application. Number one is that the amplitude and frequency of the signal generator should be made stable and well known, and the Number two, there should be a provision of controlling the amplitude of signal generator output from very low or very small to relatively large value. And number three is the output signal of the generator should not contain any distortion, and thus it should passes very low harmonic content. And number four is that the output of the signal generator should be less spurious. Okay, now is the function generator. Now is the function generator. So function generator actually produces a different waveform of adjustable frequency. It provides the mainly adjustable or different type of waveform which is adjustable or controllable. Means to control भी कर सकते हैं और adjust भी कर सकते हैं. And the function generator produces a different waveform of adjustable frequency, and the common output waveform are sine wave, square wave, triangle, and short wave. And the frequency may be adjusted from the function range of hertz to several hundred of kilohertz. In a varies the output of the generator can be made available at the same time. For example, the generator can provide a square wave to test the linearity of the rectifier and simultaneously provide a sawtooth to drive the horizontal deflection amplifier of the CRO to produce a visual output. And so function generator क्या है? Function generator produce a different type of waveform which are adjustable, and the common output waveform are sine, triangular, or sawtooth wave, and the frequency may be adjusted from a range of hertz to 1 hertz or मतलब 1 hertz to several hundred kilohertz of varies the output of the generator, and it can be made available at the same time. Means that generator can be provided a square wave to test the linearity of the rectifier also, and it is also simultaneously provide a sawtooth to derive the drive the derive the horizontal deflection of the amplifier of the CRO to produce a visual display. And the capability of phase lock this phase को lock करेगा. The function generator can be phase locked, and external source on function generator can be used to lock the second function generator, and the two output signal can be displayed in phase. Just 1 minute. So in function generator, it is the another property is that it can be locked the phase. Okay, so capability of phase lock function generator can be phase locked to an external source on function generator can be used to lock a second function generator, and the two output signal can be displayed in the phase by adjustable amount. In addition of the fundamental frequency of on generator can be phase locked to a harmonic of another generator by adjusting the amplitude and the phase of the harmonic, and almost any waveform can be generated by addition. The function generator can also be phase locked to the frequency standard, and its output waveform will then have any same accuracy and stability at the standard source. Now the block diagram of the function generator is the frequency control or the external. This is the external frequency control or external source, and this is the frequency control. They are the upper constant current source, and they are the lower current source. Here is the integrator, and here is the voltage comparator, and this is the resistance diode or shaping circuit, and here is the output. Here is the square wave, triangle wave, and sine wave. This is the output of amplifier output amplifier 1 and output of amplifier 2. So when it needed to produce the triangular wave, this it will be directly output is go to triangular, and when to produce the sine wave, it is passes through the resistance diode shaping circuit to the output amplifier, and when it is produced a square wave, then we are used a voltage comparator. We are used as a voltage comparator. We all know what is the function of upper constant current source and lower constant current source, because previously I says that when the upper current source is supplied, then the capacitor is increases the value, and the when this reach the our predefined level, then it can be symmetrical. Using symmetrical, the state is changed, and then it can be reverse direction. So capacitor is discharging, and the after discharging, when it is gets the lower level or lower predefined level, then again it can be changed, and the production is repeatedly done by this process. So the block diagram of function generator is that usually the frequency should be controlled by varying the capacitor of LC or RC circuit. This frequency is controlled by varying the capacitor of LC and RC, and in the instrument of frequency is controlled by varying the magnitude of the current circuit which drive the integrator. Means in the instrument the frequency is controlled by the varying of the magnitude of the current which drives the integrator, and the instrument produced sine, triangular and square wave with a frequency range of 0.01 hertz to several hundred hertz, means 100 kilohertz, and the frequency voltage control just the frequency control voltage regulator of two current sources. The upper current sources supply a constant current at the integrator whose output voltage is increased. I already said the increase linearly with a time, and according to the equation of the output signal voltage, a increase or decrease of the current and increase and decrease the slope of the output. is output का slope according to current increase or decrease के against वो increase करेगा और decrease करेगा. Now the voltage comparator of multi-vibrator change the state of predetermined maximum level of the integrator output voltage, which is either when it reaches the predefined of higher level or increased level, then it changes the state, then it go to the negative state or the lower level, again it changes, and this can be continuous, and the change cut of the current power supply and switch on the lower current supply. Firstly the upper current supply, then lower by using voltage comparator circuit, and switch of the lower current circuit. The lower current source supply a reverse current to the integrator, and so the output is decreases linearly with a time, and when output reaches a predefined minimum level, then the voltage comparator again change his state. पहले सिग्नल जनरेटर के क्या कर रहा था, वो मेरा जो सिमेट्री का रिले जो कर रहा था, मतलब वो स्टेट को चेंज कर रहा था. यहाँ पर क्या कर रहा है, यहाँ पर वोल्टेज जो कंपैरेटर है वो मेरा स्टेट को चेंज कर रहा है. यही जस्ट बेसिक डिफरेंस है, बाकी सारे सेम ही है. ओके, व्हेन द आउटपुट रीच द, हाँ बोलो
सर. इंटीग्रेटर के पास करंट अपोजिट क्यों लिए हैं?
सब्जेक्ट रिपीट से बोलो.
इंटीग्रेटर का इनपुट में सर.
हाँ
सर करंट अपोजिट क्यों लिए हैं? जैसे एक अपर करंट कांस्टेंट सोर्स से आ रहा है, एक लोअर से भी तो जाना चाहिए, तो अपोजिट वहां पे हम क्यों लिए हैं करंट?
इंटीग्रेटर देखो, अगर पल्स हमको एक बार पॉजिटिव आएगा और एक बार नेगेटिव आएगा, यही ना. ये देखो पल्सेस क्या है, ये जब जा रहा है मेरा इंक्रीज कर रहा है और ये मेरा डिक्रीज कर रहा है. ये तो राइजिंग एज, उसके बाद कुछ कांस्टेंट जो मैक्सिमम मेरा हायर लेवल में पहुंच गया, उसके बाद वो स्टेट चेंज कर रहा है ड्यू टू द वोल्टेज कंपैरेटर, देन इट गो टू द नेक्स्ट नेगेटिव लेवल, अगेन लो जो लोअर लेवल को सेट करेगा, टच करेगा, देन अगेन इट इज बी इंक्रीजिंग द करंट मींस अपर करंट सोर्स को यूज करेगा। तो तुम क्या बोलना चाह रहे हो अभी फिर से बताओ
सर वो
कन्या।
कि करंट करंट को सर अपोजिट क्यों लिए हैं?
ये जो एरो का बात बोल रहे हो तुम, या
यस
किसको
सर।
बात बोल रहे
सर एरो का बात बोल रहा है
हो?
कि
एक तो
जैसे एक
रिवर्स
करंट
डायरेक्शन,
मेरा।
बोलो बोलो।
सर ये करंट जो है मेरा, जैसे यहाँ करंट दो से जाएगा, एक अपर करंट सोर्स से जाएगा,
हाँ, अपर से
अपोजिट
तो
हम क्यों ले रहे हैं? और
पॉजिटिव,
सर
अपर से तो पॉजिटिव डायरेक्शन में जा रहा है, लोअर से क्या नेगेटिव नेगेटिव वैल्यू जा रहा है लोअर।
तो सर
ये देखो,
निगेटिव वैल्यू के लिए यहाँ पे तो हम लोग
ये देखो,
कैपेसिटर रखे हैं ना सर, जो हम लोग को आउटपुट में मिल रहा है।
हाँ हाँ।
तो फिर यहाँ क्या रोल है सर अपोजिट करंट लेने का? ये हम कुछ समझ में नहीं आया।
तुम क्या इस एरो के बाद बोल रहे हो ना किसके बाद बोल रहे हो? एक पॉजिटिव
नो
करंट
सर,
जाएगा, एक नेगेटिव।
एरो। सर एरो का बोल रहा है, इंटीग्रेटर इनपुट के पास।
तुम्हारे हिसाब से इसको उल्टा डायरेक्शन में होना चाहिए था, तुम जो बोलना चाह रहे हो, क्योंकि जैसे पॉजिटिव जा रहा है सर, मेरा नेगेटिव भी जाएगा, यही बोल रहे
समझ
हो ना,
में
क्या
नहीं
बोलना
आ
चाह
रहा सर, यही कि अपोजिट डायरेक्शन में हम क्यों लिए हैं?
रहे हो? अच्छा, एक ये बोलो तो, एट ए टाइम की दोनों सोर्स से जाएगा मेरा अपर करंट लोअर करंट, दोनों में जाएगा क्या?
नो सर,
दोनों से
नो सर।
नहीं जाएगा, ठीक है। तो ये मेरा एक फॉरवर्ड में जा रहा है और एक रिवर्स में जा रहा है। ये जो वैल्यू है एक फॉरवर्ड में जा रहा है, अपर जो है वो फॉरवर्ड में जा रहा है, और जो लोअर है वो मेरा रिवर्स में जा रहा है, यही बात है। ये रिवर्स डायरेक्शन में जा रहा है और ये फॉरवर्ड डायरेक्शन में जा रहा है। क्योंकि एक बार क्या हो रहा है, अपर के थ्रू क्या हो रहा है, मेरा इंक्रीज कर रहा है, मेरा कैपेसिटर चार्ज हो रहा है, और लोअर करंट सोर्स के कारण क्या मेरा कैपेसिटर डिस्चार्ज हो रहा है, यही हो रहा था ना। हेलो।
यस सर, यस सर।
तो डिस्चार्ज करंट ये होगा क्योंकि ये चार्जिंग करंट जा रहा है और ये डिस्चार्जिंग करंट आ रहा है, ठीक है। और भी यही मेन रीजन है, अगर कुछ और भी होगा तो हम बता देंगे, ठीक है। हम देखें कहाँ पर थे हम। The voltage comparator multivibrates change the state of predetermined maximum level of the integrated output voltage, and this cuts off the upper current supply and switch on the lower current supply, and the lower current supply is the reverse current source to the integrator. The lower current source supply the reverse current to the integrator, so the output decrease linearly with a time, and the output reaches। तो इस लाइन को देखे तुमने? हेलो।
यस सर।
The lower current source supply the reverse current to the integrator, तो रिवर्स में डायरेक्शन तो उल्टा होगा ना।
यस सर।
So that the output is decreased linearly with the time, and when the output reaches a predetermined minimum level and the output comparator is again changes the state and switch on the lower current source. And the output indicator is the triangular wave whose frequency is determined by the magnitude of the current supplied by a constant current source. And the comparator output delivered the square wave voltage of the सेम फ्रीक्वेंसी में हम लोग ट्रायंगल भी मिलेगा, मेरे को स्क्वायर वेव भी मिलेगा, साइन वेव भी मिलेगा. तो ये गया मेरा. एक है स्वीप जनरेटर. स्वीप जनरेटर आप लोग पढ़ लीजिएगा. हम नेक्स्ट है आर्बिट्ररी, और एक मोस्ट इंपॉर्टेंट है आर्बिट्ररी फंक्शन जनरेटर AWG. शायद हमने असाइनमेंट भी इसको क्वेश्चन को दिए है. ठीक है. तो एक्चुअली arbitrary waveform generator or AWG is a produced by arbitrary waveform generator. The waveform produced by arbitrary waveform generator can be either repetitive or sometimes just a single shot. If the AWG waveform is only a single shot, then the triggering mechanism is needed to the triggering the AWG and possibly the measuring the instrument. And AWG is able to generate an arbitrary waveform by defining the set value, that is that wave points, and enter the set value of the waveform at a specific time, and that they can make a digital or even an analogous waveform. And a result of arbitrary waveform generator is from the test equipment, and it's able to produce the virtually any wave shape is required. So it is produced any type virtual any kind of wave shape which are required for any kind of instrument or electronic equipment testing purpose. It is produced virtually. The arbitrary waveform generator technique is that there are a number of ways for designing the arbitrary waveform generator. They are based around the digital technique, and their design falls onto one of the two main categories. First of all, direct digital synthesis or DDS. This type of arbitrary waveform generator is based around the DDS or direct digital synthesis technique and of the frequency synthesizer, and sometimes it may be referred as a arbitrary generator. And the variable clock arbitrary waveform generator, the variable clock arbitrary function generator is a more flexible from of arbitrary waveform generator, and these arbitrary waveform generator are generally more flexible, although they have some limitation not passes by the DDS. And sometimes these generators are referred to as adjust a arbitrary waveform generator, and AWG is rather than arbitrary function generator. And the combined arbitrary waveform generator, the format of AWG combine both of the others form, including the DDS and variable clock technique. In this way, the advantage of both system can be realized within a single item for test equipment. So arbitrary waveform generating technique is the two technique. First one is the DDS and second one is the variable clock type. And last one is the combination of these two, we can get the advantages of both. Means जब combine करते हैं तब दोनों का advantage हम लोग को मिलते हैं. So this is the basic arbitrary generator. This is the phase accumulator, waveform map, and DAC and low pass filter, and get the final output which are the required wave shape. So in this arbitrary function generator, basic is that it generates the based around the DDS type of frequency synthesizer, and sometimes it may be referred as a arbitrary function generator or AFG. The arbitrary function generator use a integrated circuit to indicate intended for direct digital frequency synthesizer and but enable the arbitrary waveform generator circuit to create a relatively easily or economic process, and to look at how the arbitrary function generator works, and it necessarily look at the operation of direct digital synthesizer, and this circuit is operates by storing the points of waveform in digital format, then it recalling them to generate the waveform, and these points can be any of the repetitive waveform that is required, and the rate of DDS completes on waveform covers to the frequency, and the basic block diagram of DDS is the of as a arbitrary waveform generator is this. This is the phase accumulator, which is the frequency information or phase increment, and this is the fixed frequency clock signal. Here is the phase accumulator, मतलब दोनों का phase को accumulate करते हैं, and then the operation of DDS with the arbitrary function generator can be emphasized by looking at the way of phase progress over the course of one cycle waveform, and the phase of 10 depicted as a line of phasor rotating around the cycle, and the phase advance around the circle is corresponding to advance waveform, and the faster progress and the sooner it the complete cycle, and hence is the higher of the frequency. And the digital synthesizer operates by storing various points of required waveform in digital format of memory. Then it can be recalled to generate the waveform they are required and simulate the phase advance in a phase accumulator is used as the phase accumulator used, and this takes the phase increment information and clock pulses from the clock source. This is the phase increment information, and this is the fixed frequency clock signal. And for each clock pulses, the phase will be advanced a certain amount, and greater than its increment, the larger phase advance, and hence the higher frequency is generated, and at the each clock pulse of phase information is presented to the memory, and the relevant location is accessed and providing the waveform information for particular phase angle, and it can be seen that any waveform can be loaded into the memory, and although the sine wave is shown in a diagram, and the actual waveform could any while the possible load current preset waveform into the memory, and it is also possible to load the user generated one in as well, and this makes the test instrument an arbitrary waveform generator or arbitrary function generator rather than the standard function generator. So what is the advantages or disadvantage of AFG? Why the arbitrary function generator is or DDS based version for arbitrary waveform generator, and how many advantages and there are some disadvantages also taken in the account of choosing the signal type of signal generator to use. The arbitrary function generator advantage is that by sub-hertz frequency resolution, by using long word phase accumulated in a DDS technique, it is possible to achieve the sub-hertz frequency resolution and downsampling and digital modulation. And disadvantage is that waveform jitter. Waveform jitter is an issue with the arbitrary function generator because the frequency are upsampled or downsampled, and this result the missing of the pulse. Hence, the jitter means upsample or due to the downsample, there will be some pulses is missing, so we could not getting the uh, exact waveform, and hence this is called jitter. Only the frequency equal to the clock frequency is divided by the waveform length, and its sub multipliers are not sampled, and this frequency and there is a not सॉरी देयर दे डू नॉट सफर दिस प्रॉब्लम। तो इस प्रॉब्लम जो जिटर मतलब अप सैम्पलिंग और डाउन सैम्पलिंग के कारण जो हमारा जो सम पल्सेस मिसिंग होता है, तो उसको रिकवरी कैसे कर सकते हैं? ओनली द फ्रीक्वेंसी इक्वल टू द क्लॉक फ्रीक्वेंसी इज डिवाइडेड बाय द वेवफॉर्म लेंथ एंड its sub multiples are not sampled and therefore do not suffer this problem. ओके, आज यहाँ तक ही रखते हैं, ठीक है। और ये मटेरियल हमने ऑलरेडी अपलोड कर दिए हैं, आप लोग अगर पहले से एक बार स्टडी कर लीजिएगा तो और भी इजी होगा। ओके, एंड फॉर टुडेज क्लास।